5.5, this is inequalities involving absolute value. Inequalities involving absolute values. All right, now, to do this problem, we first of all have to go back to the old equation problems because I know many of you struggled on this. So let's do a little review here first. Okay, when we had the problem, the absolute value of x plus 5 equals 17. Notice this isn't an inequality, it's an equals. We had two different cases. Case one is when the part inside of the absolute value is positive. So case one, part in absolute value is positive. Okay. Case two is when you do the calculations and the part in absolute value is, as many of you already guessed, negative. Okay. So if we go to that, back to the first problem or the example that I have there, case one, we have x plus 5 is equal to 17. The absolute value part is positive. I subtract 5, and I get x equals 12. So if the x plus 5 part is positive, obviously x equals 12. 12 plus 5 is 17. Okay, all works out. It's positive. Okay, case 2 is when it's negative. So that means the absolute value part, the x plus 5 part, is negative. And that equals 17. Now, if you remember from back in that chapter, we just said, well, let's write x plus 5 equals a negative 17 as our second case. Well, this is why it is that second case. This is what happens here. I initially multiply both sides by a negative 1 right away. So then I get x plus 5 is equal to a negative 17. And that's important in an inequality because when we multiply both sides by a negative, the inequality reverses. I'm going to subtract 5 from both sides, and I get x is equal to a negative 22. So when is the absolute value of x plus 5 equal to 17? It is when x equals 12 or a negative 22. Okay? Notice there are two answers. Many of you on your quiz and your test got that wrong because you forgot that there were two answers. We have 12 and negative 22 as our solutions. Okay, now we have two scenarios with absolute value inequalities. Okay, we have scenario one where the absolute value inequality, inequality, in my notes I have inequalities, yeah, we can do that. Inequalities are less than, okay? Less than. I really can't put those lines there because you'll think it's less than or equal to. But it's just less than or less than or equal to. But it's absolute value inequalities when we are less than, okay? In this situation, okay, you have the two cases to consider. Okay, you still have case one when the absolute value is positive. And case two, when the absolute value is negative. When it is negative. the solution, when we get to the final answer, the solution is the union. The solution is the union of the two cases. Of the two cases. Okay? It is the union of the two cases. That's important to know. So let's take a look at an example. Example. Absolute value m plus 2 less than 11. Remember, we have two cases. We have case 1. That's when it's positive, so we get m plus 2 is less than 11. And we have case 2, when the absolute value of m plus 2 is negative, is going to be less than 11. So in the absolute value part, inside the absolute value part, because when we do absolute value, we always get positive. So, but when we do the absolute value part, if that is negative, we have that case 2. Subtract 2 from both sides here, we get m is less than 9, case 1. And over here, I multiply both sides by a negative, so it's m plus 2 is greater than a negative 11. Remember, we multiply both sides by a negative, the inequality reverses. I subtract 2, and I have m is greater than a negative 13. The solution is the graph, or the union, of the two parts. Okay. All right. So with that, we have negative 13, open circle, m is greater than. And here at 9, we have an open circle, and it's less than. Okay. So it is when one or the other occurs, but I said union. The solution is m bar such that a negative 13 is less than m less than 9. That is our solution to this problem. Okay, now the question might be, why isn't it like all possible answers? And this is why. Because when it is less than 11, okay, when it's less than 11, it needs to be between a negative 3 and 9. Okay, because the absolute value of m plus 2 needs to be less than 11. The distance from 0 to 11, the distance, it needs to be between a negative 3 and 9. It needs to be in between those values. If it was greater than, then we'd have a different situation. But it's less than 11. So we have to get values that are less than 11. If I put a 10 inside of my absolute value, 10 plus 2 is 12. Absolute value of 12 is not less than 11. That is why I cannot include the part from this arrow here. Okay, I cannot include, I can't go past the 9. I can't include this stuff out here, even though that is greater than a negative, that should be 13. That is greater than a negative 13. Yes, 12 is greater than negative 13, but it is not also less than 9. It needs to be in between here, or it will not be inequality. Check your numbers is the easy way to explain that. Here's another scenario, a unique scenario, and that is when we have the absolute value of y minus 1 is less than a negative 2. Okay, think about that for a second. When can absolute value be less than 0? Correct. Never. Absolute value can never be less than 0. So I don't even have to work this problem out. I know the absolute value of anything cannot be less than 0. Therefore, the answer in this problem, oh, there's the buzz. Therefore, the answer in this problem is, that's right, for those people that didn't get right on the quiz, it is empty set. There's no solution. Empty set. Cannot be less than 0. That's part 1. There's going to be 3 parts to this video series.